Hey everyone, our group has been looking at the growth of cities that are seen in space. We will be presenting the contribution of remote sensing, what technologies are being used, an example of urban growth is studied from space, and the future application of remote sensing urbanization. Cities all over the world are growing rapidly because of population growth and the migration of rural people seeking economic benefits of cities. As a result, natural land covers are being replaced with impervious surfaces, which impacts the land's temperature, hydrology, structure, and ecology. We can spot changes in land cover through time, its consequences, and then decide on sustainable solutions to prevent all the negative impacts of urban growth.
Urban areas are central to sustainability. They are responsible for more than 75% of the world's GDP, more than 75% of carbon emissions, and more than 2 billion tons of waste a year. The global urban population is also growing by approximately 1 million every week. So mapping global urban expansion is vital for research in impacted environments concerning land use, biodiversity, climate change, and hydraulic systems, which I will talk more about in the next slide. In terms of land use and cover, we can track urban growth, determine drivers for urban demand, estimate population and densities, and foreshadow future urban. In terms of land use and cover, we can track urban growth, determine drivers for urban demand, estimate population and densities, and foreshadow future urban growth. In terms of biodiversity, remote sensing can readily detect habitat fragmentations that are affected by urban expansion. These habitats can include grasslands, deserts, pastoral lands, production, and native forests. In terms of climate change, land conversion increases greenhouse gases, anthropogenic heat discharge, and impervious surfaces. So thermal sensors can help monitor the ongoing drastic climate changes that we're experiencing today. In terms of hydraulic systems, during surface runoff, the flow vector and water depth are affected in urban areas, which are caused by the height of buildings, geometry of roads, and etc. So SAR data can be used to help map hydraulic processes and flood dynamics. So what we learn about urban areas and the environmental changes from remote sensing can be important for our governments and decision makers in order to create their policies for a more sustainable future.
Earth-growing cities are monitored mostly by the Landsat, MODIS, and DMSP-OLS satellites. The Defense Meteorological Satellite Program consists of 4 operational satellites, each with various onboard sensors. One very sensitive light sensor, known as the Operational Line Scan System, can detect light sources on Earth's surface at night, allowing it to locate populated urban areas. These frequent and highly sensitive images can become even more beneficial after undergoing time series analysis. This can reveal both slight changes to light sources as well as significant differences over time. Advances in technology, as seen with the progression of Landsat satellites and the recent Landsat 9 launch, have resulted in ever-increasing finer spatial resolutions. This allows for more detailed views of the surface and enables more accurate visualization of growing urban spaces and cities. This collected data is then studied and mapped using programs such as Google Earth Engine, which allows for over 40 years of Landsat data alone to be analyzed.
This paper, titled A Framework for the Long-Term Monitoring of Urban Green Volume Based on Multitemporal and Multisensoral Remote Sensing Data, was published in 2019. Researchers compiled datasets for every 6 years between 1992 and 2016 in the city of Potsdam, Germany. They were hoping to assess 2 things: the green volume area, that is trees, shrubs, etc. per meter cubed, and the degree of soil sealing across the city. Soil sealing meaning the percentage of impervious surfaces, pavement being 100% impervious, gravel 75%, etc. To assess this information, they used supervised land cover classification of the city and DTMs and DSMs derived from LiDAR or 3D surfaces created using stereo pairs. So what? As the global climate warms, cities which already experience higher temperatures due to urban heat island effects are at increasing risk. Greenery and green spaces can help regulate these temperatures. An informed understanding of both the amount and distribution of our green spaces can help inform sustainable urban planning policies as these areas continue to grow. This study is particularly cool because it didn't just look at 2D green land cover like grassy parks, but considered the volume of greenery which has the potential to include trees lining paved streets. This is just one example of how satellite monitoring of urban sprawl can help inform sustainable planning decisions in the future. Like most research in the field of remote sensing, improved spectral, spatial, and temporal resolution will only bolster the capabilities of these studies.
To continue researching urban development using remote sensing in the future, there are 4 main directions or improvements needed. First is high temporal frequency analysis. Historically, remote sensing of urbanization has only been mapped every 5 to 10 years because it was assumed to be fairly stable. But urbanization is actually a highly dynamic environment, so temporal frequency needs to be increased. Secondly is structure in 2D, 3D, and urban form. Urban form in simple refers to how an urban area is laid out and its structure. Monitoring urban form provides lots of useful information, such as its association with greenhouse gas emissions. It has been shown that compact urban forms reduce CO2 emissions from transportation due to reduced travel times, but comes at the cost of urban heat island effects. Thirdly is the characterization of urban heterogeneity. Essentially, this is the idea that remote sensing currently refers to the world as binary, urban and non-urban. But what is considered urban changes depending on where you are in the world. In the future, creating different urban classes would help detect how urbanization differs around the world. Lastly is emerging urban data. This covers the concept of how remote sensing mapping only focuses on physical features and not the underlying urban information, such as the land use. Incorporating outside data sources of urban areas into remote sensing would help in further understanding urbanization. In conclusion, we have covered 5 main topics. What is urbanization? How is remote sensing applied to detect urbanization? What type of information does remote sensing provide in this field? A case study and the future of urban remote sensing research.